Hello everyone. In this video, I will be demonstrating my automated resume relevance checker, an AI-powered tool designed to instantly score a resume against a job description. We import all the necessary libraries, including Streamlit for our user interface, LangChain, and LangGraph for building our AI agent, and of course, the Google Gemini model, which is the powerful brain of our operation. We are also using a Hugging Face embedding model to turn text into meaningful numerical representation, which is crucial for our systematic analysis. Uh, the first step, uh, the first step is getting the data. Our application accepts a resume and job description in either PDF or docx format. These simple helper functions use libraries like PyPDF2 and Python docx to reliably extract the raw text from the uploaded files, making it ready for our AI to analyze. This is where LangGraph comes in. LangGraph allows us to define our AI workflow as the stateful graph. This analysis state object is like our agent's memory as it moves from one step to next. It stores all the updates, information like the extracted skills, different scores, and the final feedback. It ensures every step has the context it needs from the previous ones. Our analysis begins with the parse JD node. We can't match our resume if we don't deeply understand the job requirements. So we send the job description to Gemini model with a specific prompt. You are an expert recruiter. Extract the most important must-have skill for this JD. The model returns a clean, comma-separated list of most critical skills, which we then save to our state. Next up in the hard match node, this is our baseline analysis. It performs a classic keyword search. It iterates through the essential skills Gemini identifies and checks if they are explicitly mentioned in the resume. This gives us a hard match score if it's fast and simple, but it's not very smart. It can't understand context. For example, it wouldn't know that experience with AWS cloud service is related to S3 and EC2. And this brings us to the core of our project, the semantic match node. This is where real magic happens. This node forms a semantic search which understands the meaning behind the word, not just the word themselves. Here's how it works in three steps. First step, chunk and embed. First, we take the resume text and use our Hugging Face model to convert it into vector embeddings. Think of it as turning the resume into series of coordinates on a map of meaning. Second step, store and retrieve. We store these vectors in FAIS's vector store, which is incredibly fast at finding similarities. When we get the job description, we use it to find the most relevant chunk of the resume. Even if they don't use the exact same keywords, this is a classic retrieval augmented generation or RAG pattern. The third step, analyze and score. Finally, we send these highly relevant resume snippets along with the original job description to Gemini. We asked it a much more intelligent question. Based on this specific evidence from the resume, how well does the candidate's experience align with this job? Gemini respond with a nuanced percentage score or semantic score.
Building on the initial analysis, I will explain how our application combines the raw scores into a final verdict and uses AI to generate personalized, actionable feedback. So, our agent has now performed both a keyword and a semantic analysis. But what do we do with these two different scores? That's the job of our next node, the scoring. Here we combine the hard match and semantic match scores into a single final relevance score. We have set it up to a weighted average, giving more importance 60% to the smarter semantic score. This reflects our belief that understanding context is more valuable than just matching keywords. Based on this final score, we assign a clear verdict: high, medium, or low suitability. But our goal wasn't just to build a grading tool, we wanted to build a coaching tool. That's where the feedback note comes in. This is one of the most powerful parts of our application. First, we identify exactly which required skills from the job description were missing from the resume. Then we call the Gemini model a final time. But this time, the prompt is different. We tell it, you are a helpful career coach. We provide the final score, the verdict, and the list of missing skills. Gemini then generates concise, encouraging, and actionable feedback, helping the student understand exactly how they can improve their resume for the next opportunity. It turns a simple no into a learning experience. Now, how do all these individual steps connect? So, that's the beauty of LangGraph. Here, we define the entire application flow. We add each of our function as a node, and then we literally draw the lines between them by adding edges. We set the entry point and define a clear path. Parse the GD, run the matches, calculate the score, generate feedback, and then end. This makes our logic incredibly easy to read, manage, and debug. It's like a flow chart of our AI.
Now, let's see our final product. We have wrapped our entire LangGraph agent in a clean and simple user interface using Streamlit. On the left, you can upload or paste job description. On the right, you can upload the candidate's resume in either PDF or docs format. And with a single click, our agent gets to work. You see the spinner as it runs through every node in our graph, parsing, matching, scoring, and generating feedback. And here are the results. We get a clear immediate relevance score with a verdict. The progress bar gives a great visual indicator. And for the details, we can open this expander. It shows the breakdown of keyword versus semantic scores, lists the specific skills that were missing, and most importantly, provides that personalized AI generated feedback from our career coach. It's fast, it's comprehensive, and it's incredibly helpful.